Hello everyone. Today I'm going to present our paper blockchain based root of trust management in security credential management system for vehicular communications. So the authors are me, Arijit Sharkar, Sang-hyun Woon, Dr. Wenjun Fan, and Dr. Sang-un Chang. And this is presented by me, Arijit Sharkar. So here first I will discuss about the overview of the presentation. So first I'll go through the background related to the vehicular networking and SCMS, and then I will present the contribution scope of our paper, and then the proposed model which we call BBRM, a blockchain based route management, and then I will present the analysis of our proposed model. So the vehicular networking actually it serves as one of the most important technologies to implement lots of applications related to vehicles, vehicle traffic, drivers, passengers, and pedestrians. So here actually we have like in each vehicle there is an equipment called onboard equipment, OBE. So this has a communication channel with roadside equipment, RAC, and RAC have communication channel with the any specific application server via the router and internet. So this is like a very high level diagram of vehicular networking. So here the OBE and RAC, so they exchange messages, but like how to trust these messages, like one OBE how it can trust the message from RAC, or one OBE how it can trust message from another OBE. So here to solve this problem, that SCMS has been developed. So SCMS is Security Credential Management System. So this has been developed by the Crash Avoidance Matrix Partners LLC, CAMP LLC, under a cooperative agreement with the US Department of Transportation, US DOT. And in that CAMP LLC, so they have BSC5 consortium. So this includes companies like Honda, Ford, Nissan, Hyundai, Kia Motors, Volkswagen, Mazda, General Motors, like that. And this work is sponsored by the National Highway Traffic Safety Administration, NHTSA. So to build this trust, so a PKI system is needed, so that these vehicles and that roadside equipments, they can trust each other. So SCMS is that public key infrastructure for that vehicle to vehicle and vehicle to infrastructure security, or combinedly we can call it vehicle to everything security, V2X security. So SCMS issues digital certificates for participating vehicles and infrastructure devices for trustworthy communications among them. So like those devices and vehicles, they can trust each other, they can trust each other's messages. So and it is designed to maintain privacy both against SCMS insiders and outsiders. And so this is the SCMS early design in like 2013. So this is called standard PKI hierarchy. So here we have RCA, Root Certificate Authority, which provides certificate to Policy Generator, PG, Intermediate Certificate Authority, ICA, and Misbehavior Authority, MA. and ICA provides certificate to Registration Authority RA, Enrollment Certificate Authority ECA, Pseudonym Certificate Authority PCA, and Linkage Authorities LA1 and LA2. And ECA and PCA, they provide certificates to end entities like roadside equipment and onboard equipment. So this was the early design. So it's called standard PKI hierarchy. So then in 2018 the design updated and the concept of EBRM came. So here that green dashed rectangle, so this represents the EBRM. So this is actually a set of electors to select the root certificate authority. So this is a distributed mechanism, and so our work is focused on this EBRM, elector based route management. So here electors, they vote for a route certificate authority, and they do it by assigning a route endorsement. So why actually it is needed? Because that RCA or elector certificates validity period may be in, or a revocation may necessary if like RCA misbehaves. So for this type of things, like this is needed, and these electors, they have the power to change the RCA or elector using voting mechanism. And elector based route management introduces a ballot with endorsement. So what is the endorsement? Endorsement is actually a vote that is casted by the electors for a given RCA or elector. So it can be either like adding a root RCA certificate, revoking RCA certificate, adding elector certificate, and revoking elector certificate. And these endorsements, those are aggregated into a ballot. And when a quorum of valid elector endorsement is presented in a ballot, then that certificate is trusted, and that certificate becomes valid. So the definition of quorum is defined in the global policy file. So it's actually the majority of the elector votes. So the number is defined in the global policy file, and these electors are not part of the PKI hierarchy. So that's why a different crypto system can be used in elector based route management. So we used a blockchain in elector based route management. So the problem here is that electors, they are selecting RCA, and RCA provides certificates to the authorities like PG, ICA, and MA. So RCA can be subjected to the single point of failure. So in the EBRM. So that's why we have tried to replace that RCA with the blockchain, so that we can solve the problem of single point of compromise. And another problem is that the ACMS manager, so they actually collect the votes from the elector. So elector votes for either like selecting or revoking any elector certificate, or it can be any certificate of the RCA. So those votes are collected by the ACMS manager, and then ACMS manager provides those votes to policy generators. So in this case, that the problem can happen that again that a single point of compromise can happen. So that's why we introduced here the blockchain, so that we can avoid the single point of compromise. So here what is the our proposed proposal. So that is the replacing the voting process in EBRM using a permission blockchain. And in this case we are using two types of certificate. So one is a root certificate. So root certificate here, those certificates are provided to PG, ICA and MA by the electors. So we don't need any RCA. And there is also another type of certificate that is called EC, elector certificate. So that is needed to provide to the elector, like in elector election, to select or revoke any elector certificate, this certificate is needed. And in BBRM we have access control rules to provide the option of who can access, read and or write in the blockchain. So in BBRM blockchain we have electors who can read or write, and the verifiers which are actually PG, ICA and MA. So they have only the read access in the BBRM blockchain. So what is the advantage of applying blockchain in BBRM? So here actually BBRM applies blockchain for two functionalities. So one is RC, to replace the RCA, to make the SMS simpler and get rid of the corresponding vulnerabilities such as single point of failure, and also that EC to manage the elector network control. So and here another property is that immutability. So once the transactions are available in the network, so it cannot be changed or altered for manipulation, and it has already that vote of the electors via the distributed consensus protocol. So that's why it is trustworthy, the generation and revocation of RC or EC. And another property is that the transparency. So this transparency actually provides greater accountability, because that the certificates are available to all the verifiers and also the electors, so they can see like who has voted for whom. So this provides a greater accountability. And in using the blockchain we can also have the automatic synchronization with RC and EC states, and it also provides the distributed consensus which actually makes it appropriate for the EBRM. So here we have 5 functions. So first 4 functions can be called as voting function: add RC, revoke RC, add EC, revoke EC. So this actually add RC is for selecting any root certificate, revoke RC is for revoking any root certificate, add EC is for adding any elected certificate, and revoke EC is for revoking any elected certificate. So these 4 are called voting transaction. And we also have a query function. So using the query function, any reader or writer, they can query about any specific transaction and read that transaction. So here we have actually 2 types of transactions. So first one is the initiative transaction, and second one is the vouching transaction. So in initiative transaction, vouching transaction, actually they have the same certificate value, but only the value of issuer information, digital signature and hash value are different. So because here like this is actually the electors, they are providing certificate to any other elector or any for any other root certificate. So that's why that issuer info varies. And initiative transaction actually starts the voting round. So this is called a first vote in the round. And then vouching transaction, this supports that initiative transaction. So an elector starts a voting round by broadcasting initiative transaction, and other electors, depending on their choice, they can submit a vouching transaction for that initiative transaction. If they don't support that initiative transaction, they don't need to they don't need to submit that vouching transaction. And if the initiative transaction gets majority vote including the transaction itself, then the certificate is selected. So now I'll talk about the BBRM implementation. So for our implementation, we used Hyperledger Fabric, and for the blockchain environment, and for the language of a smart contract, we developed by using Go language. So in SCMS, it is said that 3 electors are needed for proof of concept and 9 electors are needed for the actual deployment. So we actually did the implementation for 3, 5, 7 and 9 electors to see like how it goes for the analysis, how we can measure that. And so in our case, like we did that implementation in a single Windows machine, in a physical machine in Windows, and in that physical machine we had several virtual machines to implement each elector. So the configurations of those virtual machines are for operating system we used Ubuntu 16.04 64-bit. For RAM we used 2 GB DDR3, and for CPU we used Intel Core i7 1 core 4 GHz. So now I will say something about the analysis part. So here actually you can see that the event is actually a voting round where a certificate has made viable, and minimum votes and maximum votes is the minimum number of votes to make that certificate viable, and max votes is a maximum number of votes to make the certificate viable. So we did the analysis for 3, 5, 7 and 9 electors. So for 3 electors we can see that for minimum votes it needs like 14.01 kilobyte per event, and for 9 elector it needs like 62.88 kilobyte per event. So this is the range we can see the size for per event. So the transaction scalability here is that for Hyperledger Fabric, 20,000 transactions per second with 2.9 kilobyte per transaction size. So it can scale up to like this. This will be 1.829 into 10 to the power 12 kilobyte per year. So, and for our case, for each RC generation or revocation event and the corresponding EC events, it takes actually 18.68 kilobyte per year to 209.6 kilobyte per year, and this ranges from the minimum votes of 3 electors to the maximum vote of 9 electors. And again, these calculations, there can be several factors here, the block size, transaction size, network size, hardware configuration, where it can vary, but this is so this is like the Hyperledger Fabric. It can scale up to this number, but in our case it is very low. So another analysis is that the analysis of throughput. So here actually we calculated that how fast is our BBRM. So actually the throughput is needed because the verifiers, they need to be updated about the state of the blockchain as soon as possible. So here suppose if RC is revoked, but still will be used by the verifiers until the result is not reflected on the blockchain. So that's why we need to measure the throughput of our blockchain. So here we can see that for 3 to 9 electors, like it's for 9 electors, this is like 16 kilobyte per second. So if we consider this blockchain size per event, so then it's like a very less, like it will take only a few seconds to conduct one event. So this is very fast. So we also have done several other analysis for like resource consumption and latency, so which is presented in the paper. So due to the time constraints, we can't show it here. So the conclusion is that, like so the importance of EBRM in SCMS and eventually in vehicular communications, which motivates us to develop this blockchain based route management BBRM. And here our future work is to make the to generalize the BBRM design and to apply it to other advanced PKI. Thank you.